Next, I have some examples here working with quadratic functions. So a quadratic is an adjective we use to describe a certain type of a function in its equation. Quadratic functions. It's a function because it passes the vertical line test. For every input, there's only one, no more than one output. So quadratic functions. The other word we might be throwing around right now is parabola. That's the name of the graph we get when we draw a quadratic function. But a parabola, it could be really tilted a little bit diagonally. They can be completely sideways. In algebra, we just tend to focus, on quadratic functions. Now, it asks us here to find the vertex form of the following function. Then find each of the following. So here's my first example that says f of x equals, and I kind of set it up a little funny, but another way it could have been written before we had even started really could be something like f of x equals, it could have been negative x squared. I decided to put the negative as an afterthought, negative x squared minus 10x plus 24. So if we had an example like this, to put it into vertex form, we have a few options. I'm going to show by completing the square, and then I'm also going to show by finding the vertex using the formula you may be familiar with, negative b over 2a, and then plugging that value back in to get the corresponding output or y value of the vertex and kind of faking it. So there's more than one way to do this. So I'm showing first by completing the square. Okay? So right now that's what I'm going to do. Completing the square. Now, completing the square is a concept you should be familiar with. So first thing I want to do to get this into a nice vertex form is I want my x squared to have a leading coefficient of a 1 in front. So negative 1 isn't quite good enough. So I factored out that negative, so it's sort of out of the way right now. The next thing I'm going to do, well, really, I'm going to kind of unfactor it out of this 24. I'm going to kind of go back to looking like this. So next step, f of x equals negative x squared plus 10x. Now I'm going to leave some space. On the side here, I'm going to have that plus 24 from the beginning. Okay? Now I want to know what completes the square, meaning what number can I add inside of here that will enable me to factor this quadratic trinomial as being two identical factors, so that in the next step, since they're two identical factors, I can write it as something squared, and that will put me in vertex form, which we saw in the videos, for example, the piecewise function videos. Okay? Now, if I want these to both be the same, my middle, the outer, and the inner needs to add to 10. Well, what number plus itself equals 10? That would be 5. So I'm going to have a plus 5 and a plus 5. If I have two plus 5s, I can write x plus 5 quantity squared, and don't forget this negative, it's a negative 1, it's still sort of just hanging out front. Now if that was a 5 and a 5, when I expand this, x times x, x squared, 5x, 5x, I get my 10x, 5 times 5, 25. So essentially I'm adding this random amount of 25 to the problem that's actually a negative 25. You're not really supposed to do that. So if I'm really adding a negative 25, I also have to add a positive 25 to balance things out. So 24 plus 25 gives me 49. 49. So I have now, I'm going to do this, vertex form. Since I have this in vertex form, there's really no reason why I can't quickly identify the vertex. Based on my transformations, I know that I am shifting. This x plus 5 means I'm going to the left 5 units, plus 49 means I'm going up 49 units. So my vertex is at negative 5, 49. This negative in front, whether it's here in front of my parentheses or if it's up there, even over here, this tells me that my parabola will have a shape like this. If it's shaped like that, you have to really think about where negative 549 is, left 5 and up 49. That really puts this in quadrant 2. If I'm in quadrant 2, you should know that you will have 2 x-intercepts. We will always have a y-intercept though when it comes to a parabola, but you will always have an x-intercept. So we will have 2 x-intercepts in this example, so they are worth finding. How do you find x-intercepts? Well, every point on the x-axis has 0 as its y value. So what you can do is fill in 0 for the y value and solve. How can we solve? You can solve by factoring. You can solve by completing the square and getting x alone, now by taking square roots, or you can solve by quadratic formula. Any of those. Okay? What else do we know from this? If we want to know, do they have a maximum or a minimum? By looking at this, does this parabola achieve a maximum value that's clearly defined, or a minimum? Well, in this case, a maximum. If they ask for the value of the maximum or minimum, that is them asking for the y value only, not the ordered pair. If they ask what is the maximum or minimum point, then you get an ordered pair. If it asks for a value, you're going to give only the y value. Domain, well, the domain of all parabolas, all quadratic functions, is going to be all real numbers, or that fancy r, or from negative infinity to infinity, whatever way we write your answer. And the range works from the bottom to the top, and we describe all the y values that apply. So let's go ahead and fill in these answers. First thing I'm going to fill in, let's find my intercepts. That means I'm going to find my x and y intercepts. If you look at it in this form right over here, this is called standard form. If we fill in 0 for x, my y will equal what? When x is 0, I'm on the y-axis. Fill in 0 for x, gone. It's always that last number, maybe you called it the c value, so y will equal 24. So that means I have an intercept at 0, 24. That's my y-intercept. You have to write it like that as an ordered pair. So 0, 24. Now, does that make sense? I think so, and we'll elaborate on that more in a minute. What about my x-intercepts? I have a couple options. I can factor and solve. With the negative already being out, that's pretty handy. If this were plugging in 0, because to get an x-intercept, you want y to equal 0. If y is equaling 0, that's really what f of x means. F of x has to equal 0. You're not plugging it in 0. You're setting f of x equal to 0, so you're not filling a 0 for the x. Okay? Now, from there, what does that give us? We'll have negative x squared plus 10x minus 24 is equal to 0. Now, this negative doesn't matter. I could divide by the negative, it will be gone. Because if you flip a parabola over, you're flipping it over the x-axis, your x-intercepts don't change. Now, x and x multiplies to 24, adds or subtracts to 10. Be careful, 12 and 2 might look good, and so will 6 and 4. I need a negative 24 by the positive 10, so that will mean a positive 12, negative 2, zero product property, x equals negative 12 gives me one answer, and x is 2 is the other answer. So my x-intercepts are going to be these two numerical values, which I'm going to write as 2, 0 and negative 12, 0. Okay? Sorry, a little blurry. Those are my x-intercepts, and really I'm done. Now, is there another way I could have found those intercepts? Yes. If you have it in Vertex Form already, fill the 0 in for f of x when you're in this form. Negative x plus 5 squared plus 49. Also, if I filled in 0 for x, that was getting my y-intercept. 0 plus 5 is 5, 5 squared is 25. 25 times negative 1 is negative 25, and negative 25 plus 49 is 24. I got the same answer. Here, I'm going to bring this whole thing, okay, to the other side. Now, I always encourage you to pause the video and try it by yourself, and then watch me do it after to make sure you're doing it right, or at least try to get started. Don't give yourself this false confidence that you totally would have been able to do it by yourself unless you've tried. So when I bring this over, that negative is going to become positive. So I will get x plus 5 squared is equal to 49. Now, the nice thing about this is I don't have x squared by itself in the problem, so I could just peel away these layers and we take the square root of both sides. x plus 5 equals, when you take the square root yourself, you have to put plus and minus. So it's positive and negative 7. Oh, sorry, I'm totally cutting the bottom of the problem off right there. There we go. Positive and negative 7. Now really from there, I'm just going to squeeze it up here. That means I have x plus 5 equals 7, and I have x plus 5 equals negative 7, and that's what will give me two answers. Subtract 7 and I get x is 2. There's one of the answers I got before. And then here, subtract 7 and I get x equals negative 12. So there's that other answer from before. So those are my answers again. Third and final way, just super review right now, quadratic formula. Quadratic formula really is completing the square. We'll save that conversation for another day. X equals negative b plus minus the square root. B squared minus 4ac. This is a radicand. Specifically, the radicand of the quadratic formula is known as the discriminant. So x equals negative b plus and minus the square root, b squared minus 4ac, all over 2a. Now what are a, b, and c? A is negative 1, b is negative 10, and c is 24. And I promise, I kind of don't have that much space here, if we fill all of that in, we're going to get these two answers, but let's at least get some of this done. So negative b will give me 10 plus minus the square root of, I'm going to do a little mental math now, 10 squared, or really negative 10 squared is 100, minus 4ac. A was negative 1, 24 is c, so it's negative 24 times negative 4, which will be positive 96. So that's 100 minus negative was plus 96, and 100 plus 96 is 196 over 2a, which is negative 2, since a was negative 1. Sorry, I did a little mental math. If you had to pause and do it on the side, that's fine. Square root of 196, well, that's a perfect square. That's going to be 14. 10 plus and minus 14 over negative 2. Now I reduce pretzel style. What do I mean by pretzel style? I mean that both things have to reduce by negative 2, not just one of them. See the pretzel? That gives me a negative 5. Now plus minus divided by minus is minus plus, but minus plus is the same as plus minus, so don't freak out. 7. Negative 5 minus 7, that's what we had right over there really. And then negative 5 plus 7, that's what we had right over there. And we will get the same two answers of 2 and negative 12. So intercepts are totally done. Next thing, the vertex. Well, the vertex I have right there in the picture. The vertex we also get from a transformation right over there. And the last way I could kind of write down my vertex is I can use x equals negative b over 2a. You remember this formula from Algebra 2, which is going to be 10 over 2 times negative 1 is negative 2, which is negative 5. And that's what we said. Plus 5 moved us to the left 5. So my vertex is at negative 5, comma. Now I know the answer is 49 already because I completed the square. However, if you did not know that, you would take this negative 5 and you're going to fill it in. Negative 5 squared is 25. Times negative is negative 25. Negative 10 and negative 5 is positive 50. Negative 25, positive 50 is 25. Whenever you're finding the vertex, I promise that the first two terms here will equal the opposite when combined of the first term. Negative 25 plus 50 is positive 25. 25 plus 24, 49. So you'll get that y value one way or another. Next, max or min value. Well, we said it's opening downward, so we definitely have a maximum value. What is that max value? Maximum value, what is that equal to? Well, what was the y value of it? Max value is 49. It's the biggest output value the problem would give us. The domain. The domain is asking us which x values are okay for us to use in this problem. Like all quadratic functions, it's all real numbers, or we can write that as negative infinity to positive infinity. Now the range. The range goes from bottom, now this points down forever, okay, to top. So if it's pointing down forever, it goes from, and this is important, and a lot of people write this backwards, negative infinity, comma, going, stop where? Stops at the y value, that maximum or minimum value of 49. Is that number included? Yeah. There you go. Couple ways to look at it. If this is a negative in front when it's in vertex form, or a negative in front at all, then your range will have negative infinity. Negative infinity always goes on the left, so don't put it on the right. If you are positive out front, your range will have positive infinity. The other number, what's it going to be? Either k, if you look at this as hk, vertex form, if you remember that, or your max or min value. And it'll always have a bracket. Okay? So there was that examples. We have one more to try. Okay, so we have our next example. Let's find a few things here. What if we were asking for intercepts? Now I'm going to find both. I'm going to find x and y intercepts. I'm even going to indicate which is which. So first one, I think it's easiest to find is the y-intercept because you plug in 0 for x. So my y-intercept will be 0, comma, do you know what it will be? 16. So if you were thinking that, bravo. Next we're going to do the x-intercept. Oh, whoops, I'm kind of writing this funny. Now for the x-intercept, do you remember what we have to do? Think it. For our x-intercept, we're going to, actually I'm going to go like this, we're going to fill in 0 for f of x or for y, whatever way you're going to look at this. We're going to fill in 0 and we're going to factor. So 0 equals, so this got the g of x is replaced with 0. Now I'm going to factor right away instead of writing the problem again. What multiplies x squared? I'm going to have x and x, 16, but I need a 10. 16 and 16 and 1, 4 and 4, 8 and 2, minus 2 and minus 8, perfect. Zero product property, I'm going to set each of these factors equal to 0. I get x is 2, and I get x is 8. So what does that tell me? My x-intercepts are going to be 2, 0, and 8, 0. So maybe you did quadratic formula, maybe you did completing the square, really up to you. Next thing I'm going to do is find vertex form. Now if you found the vertex using negative b over 2a, you got your vertex form the cheating way, so let's do it that way. I'm going to do x equals, don't just write negative b over 2a, make sure you write x equals in front, otherwise you don't know what that formula is for. Also, if you have a hard time remembering the little formula, but for some reason remember the quadratic formula, don't forget that this is just the beginning and the end of the quadratic formula. Think about that for a second, okay? Negative b over 2a will give me 10 over 2 times 1 is 2, which is 5. So the x value of my vertex is going to be 5. Then the way you show your work best is I would write g of 5 equals, because then you're saying my y value at 5, my function value, my output value at 5 is 5 squared. Now if you have a number in front, make sure you square first and then multiply by the coefficient after. Minus 10 times 5 plus 16. I'm sorry, a little discouraged. That's 25 minus 50. Think about what I said earlier about these two numbers. Whenever we're finding the vertex, the sum or the combination of these two numbers is going to be the opposite of that. And what's 25 minus 50? It's negative 25. And negative 25 plus 16 is negative 9. Now, that was the g of 5, which is my y value of my vertex. So my vertex is 5 comma negative 9. Now let's think about this. If your vertex is right 5 and down 9, right 5 and down 9, just visual in your head, it's opening upward. How do I know that? Positive out front. So it's opening upward. I will have 2 x-intercepts. 2 and 8 makes sense. 2 and 8 makes sense for a few reasons. 5 is supposed to be in the middle. How far is 2 from 5? How far is 8 from 5? Is it the same? If it is, that's good because we should have some nice symmetry when we're dealing with the quadratic. Okay? Next thing we have, got our vertex. We needed vertex form, so we're doing it the cheating way. So how are we going to get that? G of x equals, my vertex was 5, negative 9. I have a 1 in front. I'm still going to have a 1 in front. It's really a times x minus h squared plus k. This should be familiar. So I'll have minus 5 squared, and then plus k is minus 9. Okay? Because my a value is 1. Next, do I have a maximum or a minimum value? Well, we had this little sketch. I have a minimum value. Now, what is that minimum value? The minimum value is -9. A negative number could be a maximum, and a positive number could be a minimum. So don't let the sign of the number confuse you, okay, for future reference. Next, we have our max, we have our min. Domain is a real number, so I'm not even going to write it this time. And what about the range? Okay, the range. Now let's just try the range from vertex form, okay? What did I say? I said if this is positive, you'll have a positive infinity in your range. Positive infinity is always on the right. So there, we have that. Next thing, the other number, I said you can use the k value or your max or minimum values. And the other number is -9. I also said the other number will always have a bracket. So that's sort of one way to do it. The other way to do it, from the graph, we'll have from bottom to top. The lowest, -9, and it goes up until infinity. So hopefully this helps you with some fundamentals about graphing quadratics.